Okay, so this ordered pair right here, 0, 0. If you were to input 0, 0, is there anywhere for me to even use the y coordinate? There's only an x involved in this differential equation, so we'll really only be using the x coordinate for each of these points. So your x coordinate here is 0. So when you input 0 right here, what does that tell me about the slope of the original function right here? It's going to be 0. So I want you to draw a little tiny segment with a slope of 0. Okay. What about every other point on this axis? Wouldn't every other point on this axis be the same? Because every coordinate here has an x value. So go ahead and draw a whole bunch of little slopes of 0. So we're just drawing some tiny segments with a slope of 0. Okay? So now let's move over to this next set of points. Every point right here has an x-coordinate of 1, doesn't it? So once I draw one of these segments, I could draw all of them parallel to it. So if this point, let's say this point right here is 1, 1. If I input 1 into this, what do I get? I get a value of 2. So what I want you to do is draw a segment that has a slope of 2. So I would really suggest that you count from here up to over 1, angle your straight edge so that it's really making a slope of 2. Correct? Draw a little tiny segment there with a slope of 2. Adjust your ruler or your straight edge all the way up and do all of those little parallel lines with a slope of 2.
Why are you not doing it on the origin?
The origin had a slope of 0.
Or not the origin, sorry.
I just hadn't gotten there.
Oh, okay. So
I'm going to. Yeah, we are going to. Yes, I'm going to go all the way up to over 1. What is going to happen on the left-hand side of the axis? Over here. These slopes would be -2. So could we go ahead and sketch those in also? Please, thank you. Now, if you think back to all the differential equations we've been studying so far, can't they be a whole lot more complicated than just 2x? Couldn't they have x and y? And remember how we solved them? We would separate the variables and then integrate both sides. And so you can have a more complicated differential equation than this, yes, and your field would be more complicated. It might not have all of these same like parallel slopes. Let's now move out to the x values of +2, and that's about as far as I'm going to ask you to go. We're not going to fill up this whole sheet. But if you go out to a +2, 2 anything, any of these points right here are all going to end up having the same slopes. 2 anything would be a slope of how much? 4. So that's going to be a whole lot more steep. So we need to be going up 4 over 1. They're almost vertical looking, aren't they? If we moved over again to the next set of x coordinates, what would happen to the steepness? They'd be even more close to vertical. They'd be even steeper. Now if you would go over here and draw these. Okay, so I have seen an open-ended AP question that actually did ask you to generate the slope field, but it was like this much of a slope field. It was much smaller. It only had like 9 dots on it, not all of these. So they're not gonna ask you to generate a slope field that's gonna take you 10 minutes to do. So if they do, it would just be a very small portion of it, okay?
Give you a card to do it with.
Would you have, no, you have to use the edge of a booklet, yeah, edge of the paper.
Your phone.
No, you don't use your phone. Okay, so this is a slope field. Again, it is a graph of the slopes of this original function dy dx, okay? So let's go back to this differential equation and review. Can you solve this differential equation for me? You would separate the variables. dy equals 2x dx. Integrate both sides. Y would equal x squared plus c. That means this original function, y, was a family of curves that are what shape?
Parabolic.
They are parabolic. So this is a family of parabolas that would have the vertex either at 0, 0 or at some c value, correct? When you look at this slope field, do you see that there is a parabolic shape in there? Yeah, it's like a ghost image in there almost, if you were to try to connect the slope fields. Now, this is not a dot to dot. You're not directly going to go from one segment to the next segment, because aren't there more slopes in between here and here? Yeah, there's an infinite amount of little tiny slopes in here. We just can't draw them all.
Okay.
So what if I told you to sketch the solution to dy dx equals 2x that passes through 0, 3. So sketch the solution to this differential equation, which you now have a slope field for, that passes through the point 0, 3. So this point 0, 3 would tell you where to start on your slope field, right here. And then you should try to sketch that hidden image in there. Well, we know up front that it's a parabola because we could take that antiderivative easily. That was an easy differential equation to solve. So we realize it's going to be a quadratic, a parabola. But if you were to sketch in here, don't your slopes get steeper as you move out?
Wait.
And doesn't it parallel
Don't you?
on...
That's 0, 2. We can just say it's 3.
Okay, I'm going to change it. Go through 0, 2, thank you.
Why would you get 0, 3?
Because I wrote in ink.
Oh, I did too.
Now I sound impatient. Because we wrote in ink. And so we're going to just change the problem so we don't have to change the whole graph.
Okay.
Okay? So these slopes in here should be parallel to the other slopes that you've drawn. And so then are you able to see that I did not really just connect dots, but the slopes of the actual curve at these locations would be parallel to the slope fields that you've drawn in there.